Hello class, this is a video on exercise 1.20 from the first problem set. The directions in the book aren't very clear on how to approach this problem, so what I'm going to do in this video is explain exactly what types of answers, how you're supposed to answer this, and what we're going to be looking for when we grade it. So firstly, you're supposed to use the first order language of arithmetic that the book just specified above, which has two binary functions, the plus symbol and the multiplication symbol. These are binary functions. What that means is it's a function with two argument places. Something goes on the left and the right of each of these symbols. What you have to put on the left and the right of them is terms, and then what you get is a new complex term. So this thing here, 0 plus 0, is a complex term of our language. Now, how are you supposed to use the clauses of the definition in order to explain how we arrive at these terms? Well, let's just scroll up above to look at that definition. What that's referring to is this definition here of terms in the first order language of arithmetic. We call these inductive or recursive definitions, and this is part of the grammar of the language. What this definition is doing is explaining to you what count as grammatically well-formed terms of the language. There's always multiple types of clauses in these inductive or recursive definitions. There's always a kind of base clause which explains what are the fundamental terms. Those are the terms not built out of other terms. Those are the atomistic or simplistic terms. Then there's some inductive or recursive clauses, which tells you how to build complex terms out of the simpler ones. And then there's always a final clause, like clause 3, which just says nothing else is a term. The final clause is always a kind of catch-all. And in terms of answering this problem, you never make reference to the final clause 3. You're only going to use clauses 1 and 2. So how are we supposed to do this? So let's look at the directions. It says, show that these things are terms, and do it by referring to the clauses in the definition above. That doesn't really make it too transparent what it means. So this is how we do it. Let's take problem number 1. I'll do this one with you. Explain how 0 plus 0 is actually, this expression actually is a term. Well, let me pull up this is my answer sheet, which I've been composing all my answers in for this problem set. So what I'm going to do is do number 1. So this is exercise 1.20, and this is problem number 1, where I want to show that 0 plus 0 is a term. So you can just repeat it here if you want. That's not necessary, but you do 0 plus 0 is a term. I'll just do it like this. Let's say show 0 plus 0 is a term. First, we could say 0 is a term. How do we know that? Well, let's go back to our inductive definition. There has to be a kind of fundamental way that things are terms, the base clause. So look, 0 is a term. So we know that that's a term. 0 is a term by clause 1 of the definition. Now that accounts for this bit and this bit. So then we have to say then this thing 0 plus 0 is a term by clause 2. Because clause 2 says, look, if you've got two things that are terms, we just established 0 as a term. Well, I could do 0 plus 0. Since those are terms, this thing is also a term. Because we know I'm just inserting 0 for the t1 and t2 here. Because I just established it was a term. Then I'm getting 0 plus 0. That's a term as well by clause 2. Notice what I did. Remember my previous points about reading functions for exercise 1.13. You always read functions from the inside out. Well, this definition works from the inside out too. First, I said that the innermost things are terms, and I showed what establishes they are terms, namely clause 1. Then I said what establishes the outermost thing as a term. Now, so we're pretty much done with exercise number 1, or problem number 1 here, but remember the definition, the directions. It says, and what number does this refer to? So you have to compute this and say finally, and it refers to, I'll let you do the math. Okay, so then you have to always make sure to compute it and put that in your answer too. And now you do that for all of the problems in this exercise. Now these ones are a little more complicated, and I don't want to just do all 4 of these for you. So I'm going to do a practice one down here. So imagine this is another one that's slightly more complicated. How would you answer this kind of thing? So let's show that that is a term. Well, I would say something like this. So first, 0 and 1 are terms by clause 1. You can get done with both of them at the same time. Now, why did I say 0 and 1 here and just 0 above? Because this complex term only had 0. It didn't use our other basic simple term, our other name. whereas this one uses the 0 and the 1. So I first established those are terms. Now I have to establish that this thing is a term. Notice again, I'm working from the inside out, and I have to establish this is a term. Since those are different, I need to establish both of them. So then I could say then 0 times 1 is a term by clause 2. Now how do I get that? Because remember clause 2 says, hey, if you have two things that are terms, then you can do one of them times the other one. Well, I established 0 and 1 are terms, so then I can do 0 times 1 is a term by clause 2. Now I have this, the left-hand side of this, but I don't yet have the right-hand side. So now I have to say then 1 plus 1 is a term by clause 2. And then I can say this whole thing is a term by clause 2. I can only say that once I previously established that these other complex things are terms. So notice in all of these problems, you're just going to be applying clause 1 at the beginning to get all the essential bits that you need. Then you keep applying clause 2 over and over again as you build up each of these from the inside out. And finally, don't forget to compute it at the end, because that's going to be worth a point on the problem set. Okay, hopefully, so really all you need to do is submit something like this for your answer, or submit something like this for your answer. That's all that we're looking for these. Okay, hope that helps. Thanks.